Voyager 1, a tiny spacecraft the size of a car, is drifting through the unimaginable darkness of space, 14.5 billion miles from Earth. Launched in 1977, it was only meant to last 5 years. But nearly 50 years later, Voyager is still alive, defying the odds. Recently though, something bizarre has been happening. It's sending back signals, patterns, pulses, and data that don't make sense. Could Voyager have found something in the void between stars? Or even more chilling? Has something out there found Voyager? The birth of a star sailor. The story of Voyager begins not with space flight, but with a rare cosmic alignment. In the early 1970s, astronomers realized something incredible was about to happen. Jupiter, Saturn, Uranus, and Neptune would soon align in a way that occurs only once every 175 years. This alignment would allow a spacecraft to visit all 4 planets in a single mission, using each planet's gravity as a slingshot to the next. NASA couldn't resist this cosmic opportunity. They began designing twin spacecraft that could survive the harsh radiation around Jupiter, the unknown dangers of Saturn's rings, and the decade-long journey through the outer solar system. This was the birth of the Grand Tour mission, later renamed Voyager. The spacecraft themselves were a marvel of 1970s engineering. Each Voyager probe weighed about 1,800 pounds and carried 11 scientific instruments. They were powered by radioisotope thermoelectric generators, RTGs, essentially nuclear batteries that convert heat from decaying plutonium into electricity. Without these power sources, solar panels would have been useless in the dim light of the outer planet. The construction of the Voyagers was a massive undertaking. Engineers had to design systems that could function flawlessly for years without any possibility of repair. They built in multiple backups for critical systems and programmed the computers to diagnose and fix their own problems when possible. The onboard computer had about 68 KB of memory, less than what it takes to store a single digital photo today. On August 20, 1977, Voyager 2 lifted off from Cape Canaveral. It launched first despite being number 2. 16 days later on September 5, Voyager 1 followed, riding into space atop a Titan II Centaur rocket. Because Voyager 1 was on a faster trajectory, it would overtake its twin to reach Jupiter and Saturn first. As the 2 probes sailed away from Earth, few could have imagined that nearly half a century later, one of them would still be making headlines. Not for what it was finding, but for what might have found it. The Grand Tour. Voyager 1's journey through our solar system was nothing short of spectacular. After a cruise of about 18 months, it made its closest approach to Jupiter in March 1979. What it saw there transformed our understanding of the giant planet. Jupiter through Earth-based telescopes had always been a pretty but simple-looking object, a striped ball with a mysterious red spot. Through Voyager's eyes, Jupiter became a world of stunning complexity. The Great Red Spot, which we'd observed since the 1600s, was revealed as a massive storm system that could swallow 3 Earths. The colorful bands weren't just pretty patterns, but raging storms and jet streams moving at hundreds of miles an hour. But Jupiter's moon stole the show. On Earth, but sulfur compounds that painted Io's surface in yellows, oranges, and reds like a cosmic pizza. Then there was Europa, a smooth white moon covered in cracks like a shattered eggshell. Voyager's images led scientists to theorize that beneath its icy surface might lie an ocean of liquid water. A theory that later missions would strengthen and that now makes Europa one of our best hopes for finding alien life in our solar system. After Jupiter, Voyager 1 raced toward Saturn, reaching the ring planet in November 1980. Again, what had seemed simple from Earth became gloriously complex up close. Saturn's rings, which looked like solid bands from Earth, broke down into thousands of individual ringlets, some braided, some with strange spokes, all moving and changing like a cosmic dance. Saturn's largest moon, Titan, particularly interested scientists, because it was the only moon in our solar system with a substantial atmosphere. Voyager couldn't see through Titan's orange haze, but measured its atmosphere and found it was mostly nitrogen, just like Earth's. This discovery eventually led to the Cassini-Huygens mission decades later, which found lakes and rivers of liquid methane on Titan's surface. After Saturn, Voyager 1's planetary mission was complete. NASA had a choice. They could send it to Pluto, then still considered our 9th planet, or they could direct it northward out of the plane of the solar system, beginning its journey into interstellar space sooner. They chose the latter path while Voyager 2 continued on to Uranus and Neptune. As Voyager 1 left Saturn behind, it turned its camera back toward the planets for one last look. In February 1990, at Carl Sagan's suggestion, it took a series of pictures that included what became known as the pale blue dot image. Earth, a tiny blue pixel in a sunbeam, seen from 3.7 billion miles away. Sagan's reflection on this image would become one of the most profound statements about humanity's place in the cosmos ever written. And then Voyager 1 fell silent, at least visually. NASA turned off the cameras to save power. And the spacecraft sailed into the darkness, blind, but still sensing, still listening, still sending back data about the space between the stars. The Golden Record. Attached to the side of each Voyager spacecraft is a gold-plated copper disc 12 in diameter. A time capsule meant to tell the story of Earth to any intelligence that might find it in the distant future. The Golden Record, as it's known, is humanity's message in a bottle tossed into the cosmic ocean. The story of the Golden Record is almost as fascinating as Voyager itself. NASA gave a team led by Carl Sagan just 6 weeks to decide what to put on it. 6 weeks to sum up all of human existence. The team worked around the clock, arguing passionately about what music, sounds, and images should represent our world to the stars. The final contents are extraordinary in their diversity. The record contains greetings in 55 languages, from Akkadian, a language spoken 6,000 years ago, to Wu, a Chinese dialect. There are sounds from Earth, thunderstorms, volcanoes, birds, whales, laughter, footsteps, and a human heartbeat. There's music from around the world. Bach's Brandenburg Concerto, a Navajo night chant, a Peruvian wedding song, and Chuck Berry's Johnny B. Good. The record also includes 116 images encoded in analog form, diagrams showing mathematical concepts, photos of Earth's landscapes, pictures of human activities, and illustrations of DNA structure.